Hey everyone, this is the sixth video in the Math 9 ASI series. Today we're going to be going over infinite limits and vertical asymptotes. So let's go ahead. So starting off, infinite limits. If for some c, f of x increases with the out limit at x is approximately c from both sides, then the limit as x approaches c of f of x is equal to infinity. And similarly, if for some c, f of x decreases without limit at x is approximately c from both sides, then limit as x approaches c of f of x is equal to negative infinity. So let's take a look at an example of that. So we have this function f of x is equal to 1 over the absolute value of x. So this is the graph right here, and we see if we're coming up from the left, we're going to keep going infinitely, and we're never going to stop. And the same from the right, keep going. And we see that the limit as x approaches 0 of 1 over absolute value of x is infinity. Usually you're going to get a case like this when you're plugging in your limit, you're going to get a 0 in the denominator. This is generally how we're going to get something looking like this. The same thing, but now we have f of x is equal to negative 1 over absolute value of x. So this negative being involved here is going to change the function by making us decrease infinitely from the left and right, and both sides are going to approach negative infinity. So we get that the limit as x approaches 0 of negative 1 over absolute value of x is equal to negative infinity. So like other limits, we also have one-sided limits for infinite limits. We can, we can do it pretty much the same way. So here we have the function f of x is equal to 1 over 2 minus x. And so the thing in question is we're going to be taking the limit as x approaches 2. So from the left, we see that we're going to be going up infinitely. And from the right, we see that we're going down infinitely. So we have limit as x approaches 2 from the left of f of x is equal to infinity, and the limit as x approaches 2 from the right of f of x equals negative infinity. And like before, because our limit from the left does not equal our limit from the right, then we can say that the limit as x approaches 2 of 1 over 2 minus x does not exist. So a couple remarks, things to keep in mind. Pay attention to the signs our function is like immediately left and right of our limit. This is going to help you determine whether we're going to infinity or negative infinity. So for example, the last thing we did, f of x equals 1 over 2 minus x, we see that if we plug in any value less than 2, we get a positive number. So if we plug in, we could pick something super close to 2 or something much less. So let's choose like 1. 1 is less than 2. We get 1 over 2 minus 1 is going to be positive. So we know on the left we're going to infinity. It's going to be always positive over there. And if we plug in a number x is greater than 2, then we're going to get 2 minus, let's say, 3, and then that's going to be negative for f of x. So we can see that's why we're getting negative infinity on the right. So keep that in mind. Oops. And then we have this case here. So if we get that the limit of as x approaches c of f of x is equal to 0 over 0, or the idea of negative 0 over 0, any combination of that, we say that this is indeterminate. So later on, we're going to have a way that we can deal with situations like this, but for now, we're just going to say it's indeterminate and be done with it, okay? Vertical asymptotes. So a vertical asymptote is a line x equals c if the limit as x approaches c from the left of f of x is equal to positive or negative infinity, or the limit from the right is equal to positive or negative infinity. So an example of this is looking at our previous example. We have a vertical asymptote as x equals 2. This is where our limit is equaling negative infinity on the right and infinity on the left. So you can go ahead and draw this line x equals 2 right here. And something you can notice about this is that no matter how far we increase here on the left or decrease here on the right, we're never going to cross that line. That's because our function doesn't exist at 2. So we'll get infinitely close to this line, but we're never going to cross it. Okay, so this is a bit of a short video this time. Please let me know if you have any questions. Come to office hours, comment down below, all the same stuff. Also sign in. If you can do that for me, that helps a lot. constructive feedback. I want to put out the best videos possible for you guys. And if there's any topics you want me to go over specifically, please let me know. Right now, I'm just following along basically with the lectures. But if there's anything you'd like me to go over that you guys are confused about, then I'd be happy to go over them in these kinds of videos. Okay? Thank you for watching. I hope you guys have a good day.